8 on 1.3. So I'm going to write this on another page. So the population growth in China in billions of people can be modeled by this, where T is the number of years since 1993. So I'm going to write that over here. P, not too high, of T equals 1.15, 1.014 to the T equals 0 is 1993. So just for my information, T equal 10 would be 2003. T equal 20 would be 2013. T equal 30 would be 2023. And this is a exponential growth. This is saying it's growing by, it'll have the 100% of the population percent plus 1.4% more. So it's growing at 1.4% per year. Okay. And according to the model, the total population, the total change in the population from 1993 to 2000. What is the total change? So I got to figure out the population of 1993, which is T equals 0. Which is going to be, this is just 1, so it's going to be 1.15 billion people. Okay? And 2000 would be, did they say 2000? Yes, 2000. So 1993 to 2000 would be 7 years since 93. So let's figure that out. I'm going to go to my calculator, and I'm going to y equals, and I'm going to type in this equation, 1.15 parentheses 1.014 close parentheses to the x. And now I can go to my table and find out when, let's delete when it is, when it's 7, and I get 1.2675. 1.27. So the change, 15 to 27, is 1.2. 0.12 billion of people. Okay? That's how much the number more people there were between 1993 and 2000. Okay, the next question. What is the average rate of change in the population over this time period? Okay, so that's that many people in 7 years, so the average rate of change would be 0.12 billions of people per 7 years, which is 1.2. Yeah. 0.12 divided by 7 is 0.017 billions of people per year. And continuing with A, is the average rate of change greater or less than the instantaneous rate of change? Well, if the population is growing exponentially, is the average rate of change greater or less than the instantaneous rate of change on January 2000? So here's 1993, 2000, it's curving up. So here's the slope, which is the average rate of change. And at 2000, the instantaneous would be a tangent line, and its slope would be greater than that. So the instantaneous is greater than the average. And then I explained it because it says explain and justify. Be sure to include proper units for all your answers. Okay, so we did that. Got units in all our answers, and I explained it. Okay, next question, part B. According to the model, what is the average rate of change in population in China in a 10-year period starting January 2012? So if we got to go from 2012, which is t equal 19, to 10-year period, so t equals 29. And we're supposed to figure out average rate of change. So we have to find t of 29, population at 29, minus the population at 19 over the 10 years. And so if I go to the table and put in 29, the population is 1.72 billion, minus at 19 it was 1.497, 1.50 billions of people over 10. So the difference here is 0.22 over 10, so that's 0.022 billions of people per year. This is years, and this is billions of people. So that's B. C. Write an expression involving limits if a value would give the exact instantaneous rate of population on today's date. Today's date would be, well, 28 would be January 1 of 21. So today's 28 would be January 1, and then we're roughly 3/4 of the year gone, 3 months of it, or 9 months, so I'm just going to use 7/5. And so the instantaneous would be the limit as h approaches 0 of p of 28.75 plus h minus p of 28.75 over h. Okay? And then write an expression, then estimate the value of the limit, discuss how you chose to do so, and explain the meaning of the units in this, what we found. So this will look like the limit. I'm going to move this up here a little bit. As h approaches 0, p of this would be the original equation, 1.15 1.014 to the 28.75 plus h power minus 1.15 parentheses 1.014 to the 28.75 over h. Now that's a mess to plug in and then get h close to 0. So I'm going to do it on my calculator here, but I'm going to do a little shortcut here. This already has the equation in y1. I'm going to turn that equation off so I don't see answers from it by pressing enter on the equal sign. Then I'm going to come down here and do what I have written here, which is type in y1 with 28.75 plus a variable in for that. So I'm going to go, and this is the numerator of a fraction, so I'm going to go start it with a parentheses. Then I'm going to put vars, and then I'm going to go to y variables and choose function, and I'm going to choose y1 with 28.75 minus plus x, close parenthesis, minus y1, which was vars, y variables, function, y1 with just 28.75 plugged into it, 28.75, and that ends my numerator, so I'm going to close parenthesis, divided by x, h, which I'm making be x. So now I need to pick x close to 0. So I'm going to go to my table, get rid of these, and pick x's close to 0, 0.1, 0.01, 0.001. Not changing much. How about negative 0.1, negative 0.01, negative 0.001. So it looks like I'm getting a number that's pretty consistently there of 0.0238 billions of people per year is the rate of change right now at today's date. Okay, 3/4 of a year through 2021. Okay, that was C. Now let's do D. Finding the equation to the tangent line of the function. Okay, so if this was the curve, and this is 2021, the slope of the tangent line, we just figured out, but then we have to write the equation of a line that goes through this point. And that point is 28.75. And what's the population then? So I have to plug that into my original equation to find the population. I can do that right here. So I'm going to turn the population equation back on and turn the instantaneous equation off, and then I'm going to go to second table and put in, now it's giving me y1, and I'm going to put in 28.75, and it was about 1.72 billions of people. 1.72 billion people at that date. So I have to create a line that has this slope, 0.0238 times t plus some y-intercept, or the equation for that tangent line, And so the y-intercept is going to depend on making sure it goes through this point. So when I put 28.75 in for the t, I should come up with 1.72. So I'm going to work this value out. 28.75 times the slope, 0.0238, and I get a number, 0.684. So this would be, with 28.75 in there, is 0.684, and this plus b is supposed to be this, so if I subtract that from that, subtract it from both sides, I'll figure out what b has to be. So 1.72 minus my answer there, and I get about 1.04. So there's the approximate equation of the line, because I did some rounding, of the tangent line at today's date.